if y equal to cot inverse of x, then dy dx equal to minus 1 all over 1 plus x squared. We're going to prove how we arrive at this. We've been given that y equal to cot inverse of x, and this becomes equation 1. And from trigonometry, x equal to cot y, this becomes equation 2. Now we're going to differentiate them implicitly. So we differentiate x to have 1 equal to, differentiating cot y, we have minus cosec square y dy dx. So we're going to make dy dx the subject. So dy dx equal to this minus 1 all over cosec square y. Now this becomes equation 3. So from trigonometry, cot y becomes adjacent all over opposite. Cot y equal to adjacent all over opposite, and that becomes x all over 1, so that we can draw the right angle triangle with y becoming the angle. So adjacent all over opposite becomes x over 1, and the adjacent is here, then the opposite becomes 1. We do not know this place. We'll label it as n. So by using the Pythagoras theorem, we can find this n squared equal to 1 squared plus x squared. So that n becomes the square root of 1 plus x squared. So here becomes the square root of 1 plus x squared. Now cosec y equal to hypotenuse all over opposite. And since we have found here, hypotenuse becomes this all over 1, the same thing as the square root of 1 plus x squared. Now we're going to substitute the value of cosec in equation 3, so that dy dx equal to minus 1 all over, because cosec is squared, we're going to square it here. We have the square root of 1 plus x squared, so that we have minus 1 all over 1 plus x squared, and this becomes the proof.